Salesforce deployments. So the idea behind this session is to give you an overview of some of the type of things to bear in mind when you go through the process of moving to a proper release management process. Now, before we begin, let's remember that any statements made during this talk about future-looking features and functionality should not impact your purchasing decisions, and that you should only base your decisions on what's generally available as of today. Okay, so a quick introduction. My name is Kashyap Patel. I'm from SF Apex. We provide Salesforce data tools designed for making and utilizing sandboxes more effectively and ingeniously simple. If you want to catch me after the talk or any of my team members, we have a booth in the Trailhead area as well as the Expo area as well. Okay, so the agenda for today is we're going to quickly go over the most common methodologies used in software development, and then just after that, we're going to go and get into environment strategies and talk a little bit more about DevOps. We'll take a look at how we got to where we are today, and as far as source-driven development versus org-based development, and then we'll get into a deep dive into CI/CD and continuous testing practices. So towards the end, we'll go and touch on unlocked packages and also how they can benefit your team for future deployments. Okay, so it's a interesting time to work as a release manager or developer in Salesforce because we've been going through a major revolution at the moment in terms of Salesforce DX and the introduction of Git over the past 2 years, and generally changes in the way that modern application development works. So this means that there's a great opportunity for people to make changes to the way they process and improve it to make things a little bit easier and a little bit funner to kind of work with as well. So first, let's go and talk about methodologies used most commonly in development organizations today. Now, there's your traditional waterfall approach, and which most of you are already familiar with, and so we're not going to talk too much about that. And then there's also the Agile methodology as well. And we're going to take a closer look at both of these methodologies and kind of what makes them shine and where the pitfalls are. Okay, now I wanted to start off by talking about the traditional release management process that most organizations are still following today and pretty much since the dawn of time, and it's called the Waterfall approach or the SDLC approach. Now, most folks already know about this, but this generally involves completely speccing out a very large development project by going back and forth with the business stakeholders, subject matter experts, and various other teams to figure out all the functionality and business requirements needed to complete the development project. Now, after a few months of kind of theorizing what the system should be able to solve or do, the core team then formulates a solution design document or documents which outline, again, theoretically, how the system should be designed and developed to solve those business requirements. Now, once everyone has finally gotten tired of going back and forth about the proposed solution, there we go. Now, once everybody's gotten kind of tired of going back and forth about the proposed solution and requirements and having, endless meetings, we finally get sign-offs to proceed to the next stage of implementation. Now, during implementation or the development phase of the project, developers gear up by setting up their development environments or sandboxes. They go and split up the development tasks, and then they get to work clicking and coding. Now, after a few weeks of coding, playing ping pong, and drinking plenty of Red Bull, and a few lashes from the project manager, the developers wrap up their development tasks inside their sandboxes. Now, the next step is to merge their changes into what's called a integration sandbox. And this is where development and testing teams can make sure that everyone's code plays well with one another and still works with the existing code base. Now, once integration testing is completed, they can move on to the next stage of testing. But what happens if during testing, the user finds an issue with the way something works? Well, generally this can either go one of two ways. So the first is it's a quick fix requiring minimal rework, or the other way is that you have to cancel your plans for the next 2 weeks because the fix requires changing something, a whole bunch of code inside the code base to fix the issue. Now, most of the time there are subsequent finger pointing sessions set up where teams try to find out the root cause of the issue and where it all went wrong. And then the project managers have to adjust their delivery schedules and let the stakeholders know kind of what's going on, and that it's going to be another month before the solution is delivered. Now, typically, once the dust settles and everyone comes to terms with what the core issue is, they figure out either the requirements were not wrong, or they were not fully detailed out, and now everyone is scrambling to get the project back on track. Now, unfortunately, these types of scenarios are all too common for most organizations. So let's talk about what we've learned over the many years of following the waterfall approach. So after everyone has spent a lot of time trying to figure out what the system should look like, they have to wait a few months before they get to see what the final product is. And if parts of the solution don't jive well with the ever-changing expectations of the business, teams are kind of forced to go back to the drawing board. So there's also a very high degree of uncertainty from the business user standpoint, because requirements can be misconstrued, especially if the development team is working offshore and there's a communication gap. After all, you can try to detail out every aspect of the system, but there's always a point to diminishing returns where you just have to shoot and pray and hope that the development team gets it right. So when you have a large-scale project kind of spanning over several months or years and covering hundreds of requirements, it's probably not a good idea to go with the waterfall approach, or at least may want to break up the project into different phases or help keep things a little bit more manageable. Now, the last point here kind of mentions that it's difficult to measure the progress of the development project while it's in flight. And the reason for this is that most of the requirements in the waterfall approach are highly dependent on one another and may almost rely on a common framework to be developed first before the development velocity really starts to pick up. So if the project manager is basing the schedule on solution design items getting completed, there will probably be a skew in the completion status of the overall development project. So I wanted to quickly kind of go over the Agile methodology here. And so the way that this works is typically you're taking requirements from your business stakeholders or your customers or your executive team. And those are actually being fed to the product owners of that particular system. Now, the product owners go back and they add this to the backlog, and then from a series of sprint planning meetings, they're going to go and take items off the backlog, and they're going to go ahead and put that into the sprint as well. Now, you have 2-week sprints, so the sprint team is going to go and take the items from the backlog there. They're going to go and execute the development work, and then every day you got a standing meeting, and this is generally where you're kind of going in, you're saying what are the hurdles, and then what are we kind of working on, for the day. Now, after 2 weeks is kind of completed, you're going back and doing some testing with the end users, and then at that point, you go and do the deployment there as well. Now, towards the end of the sprint, you may have a sprint retrospective meeting, or you may have a sprint review meeting. These are generally used to kind of help better future sprints as well. Okay, so now the next methodology that we kind of want to cover is the Agile methodology, and what we're going to cover in this model is that we have a project team, and I apologize for that. Well, let's see what we got here. Sorry about that. Oh, there we go. Okay, so let's go and take a look at kind of the pitfalls of the Agile methodology. So some of the core issues around this is that the Agile method does make sense for small projects. So you don't want to use this method on a project that only takes 1 week to deliver. So there's no point in breaking up a project into even smaller chunks. Now, second, you want to make sure that you have a qualified staff and that everyone has buy-in on what's expected of the team. And this is especially true for the project management team, since they'll be the ones kind of keeping the project on pace and also on track. And keeping in mind that the sprint methodology is faster paced method versus the waterfall approach. Now, before we move on, let's quickly take a minute to talk about environment strategy. And in any meaningful talk about release management, we have to know what environments we're working with. So in the Salesforce world, we primarily use sandboxes to house and run our code and configurations. So to kind of level set the audience out there, we'll again, quickly go over the different type of sandboxes that most Salesforce customers have access to. Now, starting from the left, we have our Scratch orgs, and while this icon is small, it does pack a very big punch. So these sandboxes are ephemeral, meaning that they only have a maximum lifetime of about 30 days before they automatically get destroyed. Now, these sandboxes can easily be spun up or torn down, and they don't come with any sort of metadata or data in them, but using the SFDX CLI, which we'll talk about here in a few minutes, we can easily fill them up with whatever metadata that we need. Now, there are some limitations around Scratch orgs, like you can only spin up or down about 200 of them in a day, and you can only have about 40 of them active at any given time. Now, these limits are going to vary based on the addition of Salesforce environment that you guys are running. Now, next, we also have dev sandboxes, and these are a lot more permanent. They don't actually automatically get destroyed at any point in time. And they do come with a complete set of the metadata, same as what's inside your production org. Now, it takes about 10 or 20 minutes, ideally, to spin up one of these sandboxes. And typically in an organization, you'll have about 100 of these guys available to you. Now, we also have Dev Pro sandboxes, which are just like the Dev sandboxes, but they come with a slightly increased storage of 1 gigabyte instead of the 200 megabyte limit on the Dev sandboxes. And organizations typically have about 5 of these available to them. There's also a partial sandbox, which has about 5 gigabytes of data storage capacity. And you can specify a sandbox template to use to pick out what data you want Salesforce to populate it with. Although I don't necessarily recommend this because using these templates, you can only copy over about 10,000 records per object, and it doesn't maintain the relationships between the records. Now, next we have the full sandboxes, which are a full replica of your production environment with the full metadata as well as the data. Now, generally, organizations will have one of these available to them, again, depending on the addition of the Salesforce org that they're running. And they do come at a hefty price if you want more of these guys as well. And then finally, you have your production org. And of course, this is where your business users do their day-to-day operations. Okay, so now that we know about sandboxes, how do we use these different sandboxes? So this is where really coming up with an environment strategy comes in handy. Now, this is just an example of how you can use these sandboxes, but this will vary based on your organization's current release management maturity level and the type of projects that you execute. So in this scenario, we're going to be using developer sandboxes for dev environments like POC, project and support dev, hot fixes, and development testing. And for environments that involve users to come in to do testing or require some actual data, we tend to use larger sandboxes like DevPros or your partial data sandboxes. And then, of course, for performance testing and staging environments, you can definitely use a full sandbox to kind of facilitate those sort of operations. So far we've kind of talked about the general methodologies used in software development projects, but let's take a closer look into the development flow. So on a typical development project, each developer gets their own sandbox to perform their tasks. And once they have finished coding up the tasks, they may run some unit tests and call it done. Now, after all the developers have completed their development tasks, they're ready to move their code changes into a common environment to make sure that the application is still working. Now, this is called the integration environment. The testing team, which in smaller organizations are the developers generally themselves, will log into this environment and run through the integration test scripts. And if everything looks good, they'll again promote the code base to UAT, and that's where the end users go in and perform their testing. Now, the degree of testing could vary quite a bit from organization to organization, or even based on the amount of changes, but this generally is the baseline for testing. Now, if the users are happy with what they see, then they go and give their blessings, and the release team tries to deploy everything into the staging environment first, just to make sure that everything is actually deployable and ready to push to production. And this is always a good practice if you don't want to end up spending the whole weekend doing a production deployment. And once everything is deployed into production, some sanity checks are run, and on the chance that everything works out, the team celebrates with a few beers at the local pub. Now, let's think about this for a second. So with the waterfall approach, we do all the development up front and deploy once. But we learned earlier in the session that it's probably better if we use the Agile methodology. Well, if we use the Agile methodology, we'll be releasing more frequently, which is better for the user, but we'll be going through the release motions more frequently, which means that overall we're going to be spending a lot more time on things like deployment tasks instead of the stuff that we're actually good at, which is developing code. So how much time are we actually looking at? So the scenario here in this slide estimates that if a production deployment takes on average about 10 hours to do, then by using the waterfall approach, we're only spending about 40 hours a year doing deployments. That doesn't sound too bad considering that, how many weekends I've actually spent doing deployments. But now if we use the Agile methodology, we spend almost 7 times that amount doing deployments. And that's not, factoring in deployments into our testing environments. So that really doesn't sound too good, right? So how can we leverage the benefits of the Agile methodology without spending so much time on ancillary tasks, which don't really add value to the project? So this is really where DevOps kind of came into the picture. So, now I'm sure you guys have heard a lot about DevOps in other sessions, but what exactly is DevOps? So DevOps, well, Wikipedia defines it as a set of practices intended to reduce the time between committing a change to the system and the change being placed into normal production while ensuring high quality. Now, the interesting part about all this is that DevOps is a relatively new concept. It only really became mainstream about 3 years ago. And Salesforce compatible tools, which were actually robust enough for production use, have only started showing up in the past 2 years. So prior to that, most organizations were still using chain sets and ant scripts. So on that note, let's take a quick walk through history. In the tech world, this is pretty much the past 5 years. So now since the dawn of time, Salesforce admins and developers have relied on inbound and outbound chain sets in Salesforce to perform their metadata migrations between environments. And this was extremely tedious because you had to remember every single component that you modified and pick out of a massive list to first build out your chain set. And of course, if your project lasted for multiple months, this could result in hundreds of components being modified. And then you would go and deploy these chain sets into the destination environment, hoping that it would succeed. And if it didn't, you had to go back and clone the chain set, modify the contents, repackage, redeploy it. And if you're using ant scripts, this made it a little bit easier, but still wasn't the easiest solution around. So then came SFDX and Scratch orgs. So along with using source control systems as the source of truth instead of your production org, with SFDX you could install the CLI directly into your IDE of choice, and you can spin up a Scratch org and push metadata into them relatively quickly. So this worked well for development environments, but this was still a relatively slow process to deploy the meta into the higher level testing environments. And also it was very difficult to leverage the developer sandboxes, which still required the use of metadata API to deploy into. So since the IDEs had plugins to communicate with the source control system, it was easy to pull source code down and keep the development team in sync, but pushing source code into other environments still required having sufficient knowledge about the CLI commands and a whole lot of typing as well. So around the same time, the vision of CI/CD started to spread in these very same halls at Trailhead DX and Dreamforce sessions. Now, before we talk about the specifics, let's first define what exactly is CI/CD. So CI is when developers merge their changes back into the feature branch as often as possible, and the developer changes are validated by creating a build, i.e. deploying to a sandbox, and running the automated tests against the build. Now, CD is a lot like CI, but it takes it a little bit further. So it's not only taking care of automatically testing and deploying branches, It does this throughout the higher level environments like testing and even into production. Now, there's a lot of confusion out there about what CD really stands for. And it turns out it could actually stand for two different things. So one is continuous delivery, and this is where deployments to production require a click of a button versus continuous deployment, on the other hand, where deployments to production happen automatically as long as all the test passes actually pass. So personally, I'm a fan of continuous delivery, although I'm a bit of more of a risk taker. So what does CI/CD look like when it comes to Salesforce deployments? Well, from the slide, you can see that developer orgs are communicating directly with the source control system, and that the CI/CD tooling is also communicating directly with the source control system. But the higher level environments are all going through the CI/CD tooling. So what this means is that the CI/CD tooling takes care of deployments to the higher level environments, which is going to be a real time saver for us since we're using the Agile methodology. Also, it's worth mentioning that CI/CD tools can not only communicate with the traditional software Salesforce environments, but modern tools can also work with your Scratch orgs as well. So the next thing I kind of wanted to talk about was version control and basically branching strategies. So internally within your Git repository, you can obviously have your master branch, which contains a full copy of your source code. But you can also set up multiple branches or versions or copies of that master branch, and you can perform your work on these branches. So if you think about the typical developer out there, he's got his IDE installed on his laptop. He's using the SFDX CLI as part of the IDE as well to communicate back and forth with the Salesforce DX org. Now, the Scratch org, he's performing his development, he's going testing out his code changes, and once he's got it all kind of right, he goes and pushes up to his feature branch. Now, as soon as he pushes the code up to the feature branch, that's really where the CI/CD stuff starts taking over. So the CI/CD tool will first start off by creating what we call a promotion branch. And this is really where it's going to go ahead and take a copy of whatever the next environment is. For example, it could be the integration environment. And it's going to go ahead and test out the deployment of the metadata into this promotion code branch. Now, once everything is kind of checked out on the promotion code branch, it will go and merge it into the integration branch. Now, once the source code has actually been pushed into the integration branch, it will actually go and get deployed into that integration environment, and that's really where you can go in through the UI to go and do your integration testing. Now, once everything kind of checks out in the integration branch, then at that point, we can go and have the tool go and, the CI/CD tooling, go and test out the merging into the UAT environment. So again, it kind of follows the same process where it's creating this promotion branch that's going to go and merge the source code into that promotion branch. Once all the tests kind of check out there, it's going to go and actually deploy it into that next level environment. So this is kind of like the cookie cutter model that the CI/CD tooling uses in the background. And again, this is just one example of a branching strategy, and this could vary based off the organization's needs. Okay. So now the next piece I kind of wanted to talk about here was continuous testing. So in the realm of Salesforce, there's so many different ways to test out code at every different level, and it involves many different roles at the organization. So just a quick run through of the different types of testing out there. You've got your Apex code coverage and unit test or test classes that are written. And these are really useful whenever deploying something into your production environment or your sandboxes. You can actually have these test classes run, which go and test out your Apex code. And the test classes are going to go and ensure that they're covering sufficient amount of Apex code coverage out there to be able to deploy into production, which is 75%. Now, the more advanced sort of things out there are like Selenium testing. This is really useful for if you guys are running through any sort of test scripts inside your web browser. You wanted to go and record your actions of, go and click on this button, type inside some text here, and it can go and reproduce that recording automatically. And so really great for regression testing or setting up test cases where you want to go and run some tests through the UI itself. There's also something called the Lightning Test Runner. This is still relatively new. And this is actually can be installed as part of the IDE. And so what this does is with Apex test classes, it's really testing out your Apex code. But with Aura and LWCs, you're writing a lot more JavaScript out there as well. So this Lightning test runner is really going to be able to test out your Lightning components that you've written. And it's going to help to kind of test out that JavaScript code that's been put out there as part of controllers and component and other types of markup. You also have your JavaScript linters. Again, these are part of your IDE. And these are going to really kind of make sure that the formatting of your code and the complexity of your code are still maintainable and supportable. These are generally put into CI/CD tools to kind of gate check-ins. So if you want to go and check into, let's say, your GitHub, it'll require you to pass some of these JavaScript linters to make sure that there's no issues with camel casing or code formatting and things of that nature. You also have your Salesforce deployments. Now, this is generally the last case or the last kind of gate before you actually get the code into a Salesforce environment. So if you've done everything else right, you've written the test classes right and all that good stuff, generally you shouldn't run into any issues when you do your Salesforce deployments. But if your Salesforce deployment does fail, you could definitely get information from there about the error messages and issues with the code at that point as well. Now, after you've deployed something into production, you also have your post-production testing. These are just more or less sanity checks to make sure that whatever you deployed into production is actually viable. And then, of course, you have your regression testing, which is going back through and running all the previous test cases with making sure no other parts of the application have been broken. Finally, there's things called compliance rules. So this is relatively new. We've seen it in a few CI/CD tools out there. This is really useful for setting up rules that say that, for example, the view all data permission should only be applied on the admin profile and no other profile. So these are, again, really, really useful for making sure that, you haven't inadvertently, deployed something where it's going to cause, either a security risk or, some sort of business logic to break. All right. So let's going to talk quickly about modern principles of modern software delivery. Excuse me. So some of the key aspects of the way that we should be coding or architecting our code is that we want to make it modular. So the more modular that we make our code, the less dependency it has on other code bases, which means that we can update just a section of code and still help to kind of ensure that we haven't broken any other parts of the code base. We also want our source code to be disposable as well, our environments to be disposable as well. And this really lends itself well to the continuous delivery model and continuous integration models. You also want to develop using open standards and extensibility, and I think with the recent release of Lightning Web Components, it's really a testament to that, where Salesforce is trying to get more towards open standards rather than trying to develop proprietary programming languages. And then the last part is that you definitely want flexible packaging, which supports the agile distribution model. That's really going to help to facilitate the whole continuous delivery and continuous delivery and continuous deployment models. So I wanted to quickly take a look at kind of what the future holds, right? We've kind of talked about CI/CD, DevOps, all that good stuff, but we're really, the core kind of sessions and where we're headed to is unlock packages. Now, unlock packages, for the ISVs in the room, I'm sure you guys are pretty familiar with this technology. Right before you deploy anything out into the App Exchange, Salesforce will actually kind of bundle up the code. They'll go and run a series of tests to make sure that's deployable really into any customer org that's out there. So with these unlock packages, it gives you an opportunity to kind of organize your metadata into packages, and you can have multiple packages within an org. And it helps to really kind of modularize the code. So all the code that talks to one another is kind of modularized into a single package. And so that's really going to help to kind of break the dependencies within a monolithic code base. Packages also support versioning as well. So if you need to create multiple versions of the same package and then have them interop with one another, you can definitely configure that as well. Packages also provide a separation of concern. So this is really useful for, again, not breaking different parts of the code base. And you can also kind of streamline the functionality as far as the code goes and not create so much dependencies between the various different packages. A few other things here. I mean, I think the most important point here is really the ability to move, metadata from one package to another. It used to be a very, very complicated task in the past, and nowadays the Unlock Packages team, they've actually made really good strides towards this, where if you need to move, let's say, an Apex class from package A into package B, it used to be that you'd have to deploy package A, depract those particular Apex classes, deploy that all the way into your production environment. Once you've got it out there, you take a backup of your user data, and then from there you'd have to go ahead and, again, add in that class into package B, deploy that all the way up into production, and then go and restore that user data. So that was a very cumbersome process, but they've made a lot of really great improvements around that, so you can actually move metadata between your packages out there as well. Now, the key thing around Unlock Packages is that it's going to make your packages consistent, reliable, and the fact that you can deploy it into any sort of environment. And this is going to really lend itself well for a CI/CD, where we're actually putting the code base into multiple different environments, and we don't want the deployments into these environments to fail. So by packaging it up into packages, Salesforce kind of does all that testing ahead of time to make sure that the packages are deployable practically into any sort of environment out there. The other kind of key point to this is that packages make deployments repeatable, scriptable, and trackable. Again, super helpful whenever we're doing hundreds of deployments a day into these various different environments. Now, packages don't need to be an all or none sort of thing. You can actually take a small set of your code base today, put that as part of a package, and then after that, you can then deploy that package all the way into production. So it doesn't have to be a all or none. So you can definitely get started today with Unlock Packages. Now, the next thing is that it's really going to help to make CI/CD easier and less prone to deployment errors. And I've included a small bit.ly link over here as well. There's a lady here at Salesforce who did a fantastic job putting together a bunch of documentation around modular development and how to get started with Unlock Packages. If you follow the link there, there's a ton of resources available if you're interested in finding out more about Unlock Packages. So deployments with Unlock Packages, this is just kind of a small graphic here. I know it's been in a few other presentations, but it really kind of highlights the fact of where you go from deploying individual bits of code into these various different systems to now actually deploying groups of code or packages into various different systems. And because packages support dependencies, you can actually make a single package dependent on other packages as well. So you get a much cleaner deployment model into these various different environments. And again, it's going to make sure that these deployments are scriptable, trackable, and repeatable. Okay, so I think that's good. All right, so now we've talked about a lot of stuff in this presentation, right? We've talked about agile development versus the waterfall approach. We've talked about continuous integration, continuous testing, continuous delivery. So this is kind of how it's all tied together, right? This is the overarching kind of model that we all kind of want to strive for. And it really helps to bring everything together into what we call Agile DevOps. And you'll notice that between each one of these pieces, we have continuous feedback. And so if something fails in continuous integration, we can provide feedback to the former step there as well. Okay, so just a quick kind of walkthrough of kind of what we covered during the session here today. So back in the caveman days, we started off with the Waterfall methodology using inbound, outbound chain sets. Then we kind of graduated into the Agile methodology and using SFDX CLI with the advent of Scratch orgs. And we also shifted our source code from our production org into source control systems. Then the next step was, we kind of implemented DevOps, which is the whole CI/CD tooling, continuous testing, and that really made delivery a lot faster. And then now kind of looking towards the future, it's really around unlock packages and using that within your DevOps CI/CD CT, along with SFDX and SFDX CLI. All right, great. So if there's any questions, please do stop by after the session, and we'll be more than happy to talk further about this. All right. Okay, thank you, everyone.